Okay, hey Trevor, what did we study today?
Fluid dynamics.
Fluid dynamics, right. And what is a fluid? Give me some examples. Give me 3 examples of fluids.
You brush your teeth with fluids, so toothpaste is.
Uh-huh.
Tornadoes are,
Not-
because wind is.
Wind is. Wind is a fluid.
hmm And what everybody thinks that a fluid is, liquid.
Water, right?
Water, yeah.
Water is a liquid, right? And so liquids are fluids. Is Jello a liquid?
No.
Yes, it is.
No, it's wound up tightly. It's a sock.
When you pour Jello into the container. Yeah, that was a tricky one. I was wondering what you were going to say about that one. Yes, Jello is when it's in its liquid form. Before it turns into a gel, right? It is, in fact, a liquid. Very good. Very good indeed. Okay, so what are 2 principles that make something a fluid?
It has to be free-flowing.
Free-flowing.
And it has to take on the shape of its container.
Very good. Very good indeed. Okay, so is gas a fluid?
Yes.
Yes, gas is a fluid. It takes the shape of its container and it is extremely free-flowing, isn't it? Okay, very good. So fluid dynamics is the science of?
Fluid dynamics is a science of
How a fluid behaves. Right, so we're really just discussing the properties of fluids, right? All right. Now fluids always flow. In what direction do fluids flow?
Whichever way gravity takes them.
They flow according to gravity and according to what?
To any force.
And according to pressure.
Or pressure.
Pressure. Okay, so explain to me how a pneumatic tube works.
A pneumatic tube works with high pressure and low pressure.
Okay, if you have a tube and you put something in the tube, where's that something going to go? From?
You have to have high pressure on low end, on one end, and low pressure on the high end. Like a cat. Its udder is up here containing milk with high pressure.
The inside of the cow's udder has got high pressure, right?
And when you squirt it out, it's got high pressure, but when it comes into the bucket, it calms down and gets low pressure.
Well, it goes into the area of low pressure, which is the empty bucket, right? And that's how you can get the milk from the cow into the bucket, right? Okay, so let me ask you this now, according to like water and whatnot, like oceans and stuff. What is Archimedes' principle?
Any object partially or completely immersed in water will be buoyed up by force.
Okay, the force of what?
The force of
the liquid it displaces.
The liquid it displaces.
Right.
Like if you took my mom's ring and dropped it in some water, or a rock and dropped it in some water, if it's lighter than the water it displaces, it will come up. Because first it will go down because of gravity. Although then the water comes back into where it was. It displaces water. Then the water comes back to where it was displaced and buoys it back up.
Okay, now let me ask you this though. There's negative buoyancy and positive buoyancy. Or just buoyancy.
Buoyancy is floating.
Right.
It's not floating to the top or flowing down.
Exactly.
It's just floating, like in space.
Right.
You don't float up or down. You just
right. So a scuba diver, when he's like in the middle of the ocean, at not at the hot, very surface, and not at the bottom, neutral buoyancy. That's exactly right.
When you have your car neutral, it's basically the brakes and it just stops.
It's also neutral buoyancy at the surface, isn't it?
Because you stop at the.
You're not going up any higher, and you're not going down any lower. That's exactly right. Okay, so
take a milk jug, for example. If you scuba dive with a milk jug, the lower you got, the more crushed the soda can or milk jug would be.
Right.
Because of the pressure on top.
Right. It's not just the pressure of the water, it's the pressure of
the air on top. I mean, right now you have pressure coming down on you because gravity
our
and
atmosphere.
Our atmosphere is coming down on us.
Right.
But if you hop in the water, it just adds more pressure.
That's right.
And then so you could you could crush a soda can once you finish it, or when you finish a carton of milk, you stomp on it and your foot applies pressure to the milk jug.
Right.
Although sometimes you don't need to do that. If you went underwater, the lower you got, the more crushed it would be.
Right.
Although don't try that, because if you get too low, you won't be getting back up. You ain't getting back up.
Yeah, but let's not use the word ain't. Huh?
Sorry.
Anyway, very, very good. I'm very proud of you. You did real good with this principle, and I think you got the concept pretty well, because you could sure teach it to the video here. So good job, bud.
Fluids are free flowing.
Maybe we should go out back and dance, huh? All right, Trevor, sign off there, dude.
This is Trevor signing off from TST.